The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, welcome to the webinar. Today we will talk about Pandoras Box UV mapping today, and Thomas, my colleague, helping me answering your questions. Hello Thomas.
Hello. Hello,
Thank you. Okay, let's begin with our Pandoras Box UV mapping topic. Today, we will talk a little bit about Pandoras Box UV mapping and what is UV mapping, first of all. Then we will talk about UV mapping process. And then we will go through the planar UV mapping mode in Pandoras Box, talk a little bit about remap effect, and then at the end, we will also talk about the practical examples I have prepared for you. So, what is UV mapping? UV mapping is a 3D modeling process of projecting a 2D image to a 3D model surface for texture mapping. So, like you can see here on this 3D model, we have X, Y, Z for the axis and the movement positions of the 3D model in a 3D space. Exactly the same is also for the UV mapping. UV letters are the axis of the 2D texture, which we can use for positioning our map. Let's talk a little bit about the 3D objects. As you can see, we have your rabbit shape, and this rabbit shape is created by.
Short
Yeah.
interrupt you. Can I please you to can I ask you to share your screen again, to unpause your screen?
Oh, sorry.
Then we can maybe follow better.
Yeah. Okay.
That's better. Thank you.
That's not good. Okay. I'm sorry. So let's begin with this. This one. This slide was more important. So the 3D object, it was just a shape of a spherical, and yeah, you can see the X, Y, Z, the coordinates in a 3D space, and the UV map that is also in a 2D texture. And here, oops, sorry, what happened here? Okay. Here you can see the rabbit form. The rabbit is a 3D object that is made by a polygon mesh. The polygons are the triangular pieces or the triangles that you can see here on the first rabbit, and these polygons are connected to each other or made by the vertices. So the red points, the corner points, are called vertices. The more vertices you have, the more detail you will create on your 3D object. So like you can see here, if you add more vertices or polygons into your mesh, then you will have a more detailed rabbit or whatever you have as a 3D object. So let's talk a little bit about the UV mapping process. First of all, we have to unwrap the mesh. Like you can see, I have here a cube. I have to unwrap it first, and then create the texture for this cube. Afterwards, I have to apply the texture to a respective face of polygon. So what I have to do is just to assign to all these polygons my UV map. This can be also done when you using when you can't do it in a program. It can be also done by an artist or yeah, manually. So UV mapping in Pandoras Box. We have 3 different ways to do the UV mapping in Pandoras Box. We have the planar UV mapping mode within the preview, which we can use if we have created an editable mesh. We can also use the remap effect in Pandoras Box and patching our map in the matrix patcher. So it's an external tool of Pandoras Box that we can use to do this. And the next mode is the perspective UV mapping mode, which can be also used if you have multiple surfaces and you want to project from the fixed position through all of these surfaces and using the same content. So this is where you use the perspective UV mapping mode. Okay. Let's have a look into the planar UV mapping mode and the parameters there. So as I said, it's within the preview. So if we choose the mode, you will see it's quite similar to our editable mesh mode. There we have the submesh modifier, FFT modifier, vertex, move, rotate, scale, parameter floater, and selection mode. Also the axis, which we can lock, or gizmo, FFD, and mesh visibility. So far is all of these quite similar to the editable mesh mode. And here we have the calculate UV coordinates button. This is what we have to use if we have arranged our UV map and we want to calculate it and have this form. So we need to press this button. This button can be also locked to apply all our changes live, which is also a little bit yeah, it's is a little bit not yeah not very well performant if we let it just locked. The next 3 buttons are for planar map to mesh bounds, full screen planar map, and one-to-one map. I will show you the difference in Pandoras Box for the next example, because we will have to do the panels like you can see here in the camera. I've created some panels here, put it together in a weird shape, and we will map it together. Any questions so far, Thomas?
There are actually no questions yet. Thank you, Pari.
Okay, cool. So let's have a look to our setup. Today I will use my laptop as the manager, which is connected to the Compact player. and the compact player is connected to one projector projecting on the panels. Yeah, practical applications. We will have the planar UV mapping mode, yeah, projecting on the panels today. We will also have the matrix patcher to doing the remap effect in Pandoras Box, and remapping a LED wall together. And now let's go to our Pandoras Box manager. So like you can see here, I have a compact player, and this is my UV map, which is actually in the global camera. So let's change to output number 1. You see, this is the end result, so it's already warped and mapped. I would like to show you just the editable mesh file, which is not mapped yet. We will do it together, and let's take this picture. So like you can see, the picture will appear on all of these panels. It's the same picture. Let's go to the planar UV mapping mode. Sorry. Okay, you see all of these surfaces are now in 1-to-1 map. So they are in full screen and mapping also the black around my texture. Okay, let's save this state here and go through, oops, to the welcome part. It should actually look like this at the end. I just have created a simple image in the Photoshop, and this was my my arrangement of the pixels. But you can create it however you want, so that's not necessary. I just assigned also the numbers for 1, 2, 3 to know, okay, where I have to place them. And this is what we have to do here with our first picture, the 1, 2, 3, 4, 5. First of all, we will have a look into our surface. Okay, they are now in the UV mapping on 1920 pixels by 1080 pixels. So we do not want to have it because each of these pixels, each of these parts for 1, 2, 3 is actually 250 pixels by 180. So if we know our pixels and how we have done our content, then we can simply use the inspector for the UV mapping and change our surface size. So let's change it for all of them because all of them are same resolution. 180. Okay, you have also another option if you do not know the resolution or you want to deform your surface. You can use the edit FFT modifiers to deform them. Like you can do it in the editable mesh mode, or also changing the vertex positions. But if you're not happy with this, you can use the apply one-to-one map, and then it will just change this changes you have done. Next thing is if I go again to the submesh modifier and click on apply planar map, you will see this is my surface. It is jumped to the original position of my editable mesh mode, mesh file, and it will just change its size to the same size as the editable mesh submesh. If I use apply planar map to mesh bounds, it will just create where our jump to the borders position. So like you can see, we'll just make as big as it can as the output is, but holding the deformation of the editable mesh mode, mesh file. Sorry. So as I do not want to have this deformation, I will just go with a one-to-one map and create the change the size here, or I can scale it down until I reach the size I want to have, but it will be just roughly. So and as you can see, it will also change here my my size. So but it's not accurate if you do it like this. Okay. So surface number 1. Just select it because I just only want to move this. I can move it in the preview, or I can give a position here. So it will be minus 250 for the first one and minus 90. That will be the half of my height. The second surface. Actually, I can here calculate my UV coordinate for UV coordinates for the first surface, for the first panel, by clicking the calculate UV coordinates button. So you see all of them are placed here between green and orange. So it would take the same texture for all of the others, but the first one is calculated and it's done. So the second one is x0 and minus 90 in height. Calculate again. Okay, second one looks good. The third one is 250. Oops, minus 90. Calculate the next surface and go through number 4. This one has to go to minus 250. Oops, I have changed the wrong one. Sorry for this, because I didn't select this. Okay. 250 V9 minus and 90. The fifth one, 0, 94y. Calculated to, and that's done. So now we have a calculated UV mapping for all of these panels. Just for as a reminder, you can use the output to do and see everything what you have placed on the output. So that's very important. If you have placed your editable mesh mode on a layer, you have to choose a layer. Okay. Thomas, do we have any questions so far regarding the planar UV mapping mode?
Yeah, there's a question. The question is this a pixel native workflow?
Is this a pixel native workflow? Actually, my texture is done as a pixel native for all of these panels I have here. And texture is done, I can show you the resolution. But of course, if you have some deformation there and yeah, you want to lose some or deform your sub mesh in the UV mapping mode, then it's not native anymore. And also the editable mesh mode, if it's already deformed, then it's definitely not native. Does it answer your question?
Yes, I think that answered it very correctly. So as long as I do not deform things and I use the inspector to hit in accurate values, it will, so as long as I do not deform them in any way, it will stay native. That's your answer, correct?
Cool. Any
Thank you.
other questions?
Not so far. Thank you.
Okay. Would just like to remove this one because I've already created here. And the next one, and I have some weird shapes here for fun. Okay, let's go to the next example. It is the remap effect. And I have to toggle preview this side. Cool. Now I'm on all cameras, and you can see already the picture. We'll show it also here in Explorer. So this example shows how to remap natively in case the map size has a different layout than the page size. So let's imagine you have a LED wall with a size of 3840 pixels by 540 pixels. So actually it's a double HD by half HD. The LED wall is separated into two modules. Each of them has a resolution 1920 by 540. In real, both of these modules are positioned next to each other. In the LED controller, however, the second module is patched underneath the first one. So there is a vertical alignment which results in a 1920 by 1080 pixels. This is what the controller requires as an input signal and defines the output resolution of Pandora's box. So our output resolution will be 1920, like you can see here in the inspector, by 1080. You could also say that the content needs to be delivered in the HD resolution. Your output and camera are set to HD, and the layer aspect mode adapts automatically. In short, no rescaling or any other adjustment are necessary. In case there is no specially designed content, you will need to remap the content yourself. So this is what we will do together. Actually, you can also use the Planar UV mapping mode to do this. The second option is to work with a matrix picture and video tiles. So let's open the matrix picture. I've just created it. With both workflows, you will be able to arrange, move, scale, rotate layers with different content pieces and set up particle systems, scrolling text, and yeah, whatever you have to show there. This makes it easier for you to program your designs if you use also the remap effect in such cases. The internal signal layout in our case, the vertical modules is arranged in the output. You can of course also preview the output, but this makes less sense unless you need to troubleshoot something. Let's start with a matrix picture. This tool will remap the pixels from the Pandora's Box camera. All the ones between X position from 0 to 1920 will stay, but the ones from X position 1920 to 3840 and also Y position from 0 to 540 will be moved to left down. So like you can see here on the picture here. Just as a reminder, map is the real layout with 3840 pixels by 540 pixels, and patched is the internally patched output layout for the LED controller with 1920 by 1080 pixels. For default applications, the matrix resolution is set to the output, Pandora's Box output resolution, but in our case, the map space is larger than the patch space. So we need to set up a space that covers both areas. Like you can see here, this is why it's so big. So it should cover our width, which is the largest width, which is 3,840 pixels, and also the largest height, which is 1,080 pixels. The next step is to create a video tile. As video tiles are limited to a size of 1024 pixel, we simply create one with, if I select one of them, one with 90, 60 by 540. So the half of our HD width. And create a 2x2 array in the patch view. This result in 4 video tiles in a 1920 by 1080 format. In the map view, select the bottom left tile and yeah, if we select this one, if you change the location to yeah, that's to 1920 by 0, and then reposition the bottom right 1 to 2880 pixels. Now, if you're done with our remapping process, so in the matrix patcher, what we have to do is we have to go to File and export all the map for a remap effect. And this will give us a PNG file. So let's go back to our Pandoras Box manager again. So this is our remap patch patcher. So there you can see resolution and how it's patched already. And what we have to do is to go to our output and place the remap effect, which you can use, which you can find here under Neon Effects Remap, and drag and drop it on your output, and put the image we have already exported from the matrix patcher into our remap effect, and turn the mix fader on. So let's have a look into our camera. So you can see the camera is not an HD resolution. I have changed it to, oops, to 3840 by 1080, and it has the aspect ratio 32 by 9. This is the aspect ratio of our image, so this is why we want to cover and see all the image, so that's why we have to change the aspect ratio of the camera. If we have a look into the output, you can see it's already mapped. What I have done additionally to the remap effect, I have created oh, that's the option 1. I have created a 1920 by 1080 editable mesh with 2 surfaces, and I just use the one-to-one map. So that's why it's also called here on the queue. It's a one-to-one scale. And I just calculated the coordinates, and that's it. So if let's remove this editable mesh and go back to our layer mode. It's actually not so much difference because it's already one-to-one and it's already patched. If I change this patch in the UV map to the original size, and also for the second one, it will look like default. So let's have a look there. It's not cool anymore. You can see all the artifacts, and that's not what we want. This is why we have to map it as one-to-one. Okay. So I save it again here to my output. Let's go to the second option. For the second option, I have just took the same remap effect on the output with the same file, with the same matrix patch file for the remap effect. And I have created another editable mesh file with two surfaces, and both of them are in the full resolution of the camera, 3840 by 1080. Within the mesh file, I have just moved shift the mesh a little bit to 960 pixels. So let's have a look there. If you can see it here. It's not showing in the inspector. I don't know why. But the mesh file is shifted to 960 pixels. And what I have done is I just went to UV mapping. There you can see it. Oops. I have used again here the one-to-one mesh, one-to-one map for the UV surface for both of them. Actually, the same workflow like this first option. And that's how it looks like in the output. Just looks like full screen. And both of the parts are matched together. There is also another option to not using the editable mesh files, and this is actually the same, using the remap effect of the output. Don't use the mesh editable mesh, but we have to scale it up to 2 units in X. And that's, so if I change it to 1, You can see there is again, yeah, the half of our resolution, which is the HD in width. But if I scale it up, I don't need to use an editable mesh for this option. So, do we have any questions so far?
Yes, the question again, is this a pixel native workflow again, or all of these different workflows
Yes,
you
all
just
of them.
showed? Cool, thank you.
Yes, all of them were pixel native.
That's right. There was another question. He answered it himself by looking at your screen, but maybe I can share with everybody. It's about using the matrix patcher and video tiles. So the question was, can I move and rotate groups of different video tiles together? And the answer to that is you do not have to use video tiles which fit the size of your original video tiles of the video wall manufacturer, but the video tile can be as large as possible. So the only thing you have to meet there is if you want to change, let's say 1920 by 540, you can make this as one video tile and just shift that or move that wherever you need it. Because video tiles, they don't have to be addressed, it's just changing the pixels, right? So the answer to that was just make the video tile as big as your group should be.
Yes, but I think we have a limitation for the video tiles.
Okay.
It is 1024 pixels. So the largest video tile you can create.
That's also good to know.
Yeah.
Yeah, that was it for questions. So everybody's listening, but Eric.
Hi, Eric. Okay, I think if you do not have any questions more, we are done with the UV mapping topic today. Do we want to stay a little bit more to?
Yes, we can stay some more minutes in the webinar. So just in case you have another question, just let us know. Put it in. So for a few minutes we will stay here and look for your questions. And before we will end the webinar. Thank you. Thank you, Pari.
Thank you, everybody. Thank you for listening. I hope you enjoyed this webinar. See you in the next one. Thank you, Thomas.
Cheers.